Okay, so it's time to start the session, Deep Dive into Motion Layout. Please give a warm welcome to John, Nick, Hagikura-san.
Can you hear me? Hi, my name is Nicolas. I'm the tech lead on the Android design studio tools as well as the ConstraintLayout library.
My name is John Hoford. I work on MotionLayout and Android Studio design tools.
My name is Takeshi. I work for developer relations at Google.
So today we're going to go into MotionLayout, which is a new component of ConstraintLayout 2.0. So we actually announced ConstraintLayout 2.0 at Google I/O last year, and we basically added a lot more stuff compared to ConstraintLayout 1. You have virtual helpers, virtual layouts. It's based on ConstraintLayout 1.1, so it's actually pretty stable. But essentially, you have a lot more features at your disposal to create your layout and your screens. We just released, like back in December, Alpha 3 with a few more features that we're going to talk about today. We are hoping to get an Alpha 4 in the next few weeks. And of course, like one of the big highlights of ConstraintLayout 2.0 is MotionLayout. And MotionLayout is actually a subclass of ConstraintLayout. So everything you learn about ConstraintLayout, you can use in MotionLayout. It's the same stuff. But there was one feature of ConstraintLayout that allowed us to build MotionLayout, and it's Constraint Sets. So what is Constraint Set? Essentially, the idea is that you can have all the different rules, all the different operations that build your layout. We can keep them in a single object, a constraint set. And if you can do that, it's really cool because you can have more than one. And if you can have more than one, you can decide to pick one versus another one, etc., etc. So if you have that possibility, what you can do is animate. But of course, we can go much further than that because that would simply be the equivalent of using TransitionManager. And what we were interested to build is something that is really powerful for animation at large, not just layout. And that means that, sure, we allow you to move your widget where you want, change their dimensions, etc., etc. But if you want to do a full animation, you often want to do more than that. You want to, for example, change the color of a button or things like that. So MotionLayout supports all of this and expanded on what Constraint Set supports. The other thing that we did is supporting the ability of going at any point in time during the transition between two states. And because we can do that, we can drive this transition with touch input. And that means that we also had to build a pretty powerful engine that interprets the touch event in a very physical way, and it feels very natural. So John is going to talk a lot more into all of those details. But brief things just before we go into the meat of the talk. We actually wrote a lot of documentation on available on Medium. So, this talk is only, so much. If you want to go into more details, please look at this documentation. It covers things a lot more in depth. There is 4 parts so far. We are going to actually do much more. And what we would like today is more to give you an overview of what MotionLayout is capable of, as well as some of the new things we are working on. And some of the examples we'll show you today are in the GitHub repository. And again, I would encourage you to check it out. It's very useful. Finally, you may have heard about the motion editor that we are working on in Android Studio. And it's basically something for MotionLayout. Sadly, we decided recently, the Android Studio team, to basically refocus our effort on quality and stability and speed and all those paper cuts in your flow as a developer. So we pause this effort. We're hoping to basically ship it after Google I/O. So just to give you a sense of scale.
Okay, so before we dive into a lot of little details, I thought I should just go over a very, very simple example to get you started. So let's say you wanted to simply do animation like this, right? You just want to simply have a swipe of a single view back and forth on the screen. Well, the first thing you'll do is start off with a layout. So in your layout directory, resources layout, you'll create a layout. It's going to be called MotionLayout instead of ConstraintLayout, which is what you might have used before. And it has one special little feature. It points to another file, which is an XML file in your resources XML directory. So you'd have to create this resources XML file. It's called a motion scene. The motion scene file will have all the parts that actually drive and define the animation and the motion between states. So the first thing you will notice is there's a transition. And this says how to take me from one state to another. These are two states I'm interested in. Then you will have to define the two states. You define them using constraint sets. Constraint sets provide you with an encapsulation of a lot of the information about the layout, potentially colors, things like that. So in this particular constraint set, we have specified this layout, and then we create another constraint set, and it's this layout. So essentially, we have now two layouts defined as constraint sets, and we simply would add some way of driving it. So we have to come up with something. So one of the things we can do is we can add a button. So let's say we added a button to the layout. Notice we're not even going to let the constraint sets and all of that know about this button, because if it's not known, it's not going to be animated. It's just going to sit there. We'll add a callback to this button. We'll have it move the thing. And on hitting the button, it moves. So we can do that a lot simpler inside the motion scene, because one of the big things that MotionLayout supports is handling certain kinds of events to drive the animation. In one simple case, we can simply just add the callback for the button. So this is saying on click, just on click of that button, run the animation. So you won't even have to write the callback yourself. But a better handler for some situations is an on swipe. This allows you to actually manually move the button. So as such, you'll see that you can simply just move the button with your finger, and the motion will track your finger, and if you flick, it'll flick. So all of that's being handled automatically for you, and you can get more and more sophisticated with it. So next, we'll just sort of now break down all the little components that we just mentioned and sort of take you through some of it. Takesh.
Okay. Okay, now we talked about the basic example. Let me explain that what component MotionLayout has and how these components fit together. And first, motion layout and the motion scene. So suppose you have a motion layout, and the motion layout is one of the view groups. So you can imagine it's just like a normal layout file, and views or helpers in it. And one characteristic of it is that has a reference to another XML, and that is called motion scene, which is a specific to motion layout. And this has a some components specific to motion layout, like constraint set. So we already briefly talked about constraint set, but let me talk it again because it's super important. So constraint set is an entity that encapsulates all the rules for a layout, such as where a certain view should be placed. So by having multiple constraint sets and by switching constraint sets, you can decide which set of rules to apply to your layout. So consider we have a motion scene file and a constraint set in it. And we have now two constraint sets in the motion scene. The first one represents a start state. And the other one represents an end state. And by having these two constraint sets and switching them, it allows an animation that the view is moving between the two constraint sets. Two constraint sets. Because attributes specified in constraint set are interpolated like position or dimensions. In motion layout, it covers more than usual. In addition to the position to dimension, like visibility or alpha or rotation, that attributes are going to be interpolated automatically. Also, you can specify the custom attributes, which allows you to interpolate any attributes of the views. For example, if you want to interpolate the background color by adding the custom attributes in both constraint sets, then you can get an animation like this. As you can see, the background color is interpolated based on the position of the view. So we talked about constraint sets. The next one is transition. So what is transition? The basic idea of motion layout is to switch between two or more states, and the transition is an entity that defines how you want to switch between them. So this is a simple example of motion scene file that has one transition. And as you can see, it points to it has the attribute of a constraint set start and the constraint set end. So meaning once the transition is triggered, the layout is moving between two states. Also, it can define how the transition is triggered. If you have on-swipe entity, it means the swipe gesture of the user triggers the transition. Or you could have on-click alternatively, which means the user's click triggers the transition. Okay, I talked about transition. The next one is keyframe set. So keyframe set is a set of keyframes, as the name implies. Then what is a keyframe? As I explained, the resulting states are implemented by using constraint sets. But in some cases, you may want to have intermediate states. And the keyframe is a lightweight approach to achieve the intermediate state. For example, you may want to shift your view positioned at the 30% of the screen at the 50% of the transition. Key position is an example of how you define a keyframe. So it manipulates the position of the view that is being transitioned. So let's take an example first. So consider you have a simple motion scene file which has 2 constraint sets. The resulting animation looks like the video, just like the view is moving between the 2 states. But with the addition of the key position entity, the resulting animation will look like this on the video. Because it tells the button to be shifted up by the 25% of the length of the parent in the middle of the transition. Because I specify frame position as a 50, and the frame position attributes takes int value from 0 to 100. So setting 50 means key position is becoming effective at the middle of the transition. In a similar manner of key position, key attributes allow you to specify specific value of the view at a specific point in the transition. For example, if you specify the key attribute like this, so at the 50% of the transition, you will get an animation result like this. So the scale X and the scale Y are increased, and you will also get a rotation effect. So here are the supported attributes by key attributes. So basically, which covers the fundamental view properties and some motion layout specific properties like frame position. In addition, it's also possible to specify any attributes by using custom attributes, like I explained as part of constraint set. Okay, that's it about the basic component. Nicolas will talk about.
Okay, so that should give you a good overview of how everything kind of fit together. But just to make it even clearer, let's go through a basic example. So let's say that I want to have a little animation, like the sun, to go from left to right. Looks great, right? Although normally the sun would be more up in the sky. So this is how you would use a key position. You'd set it up, and it would just do that. One nice thing here is I didn't have to specify this particular arc motion. I just needed to add the path motion arc, and the curve would automatically take a segment of a circle to do that path. So we added this because this kind of arc motion is very common in UI. So that sounds good, but again, I'd like to have a little more interesting animation here, and we could simply change the background to reflect the color of the sky. And to do that, I can use a custom attribute. As you see, motion layout can go beyond simply moving stuff on the screen. We also can really take into account a lot more of the stuff you need in animation. And it's really easy, completely declarative. You just do it in XML. And as a little nice things, just to wrap up this quick example, there's this thing that we call cycles that, when you want to define a movement, for instance, but it can actually apply to more than movement, can apply on any attributes that are cyclical, you could build them like you build with the key position and stuff like that. Imagine a ball that bounces on something. That would take you a while and a lot of keyframes. So cycles makes it a lot simpler. And here is what it can look like. And one thing here that's pretty cool is it's a time cycle, meaning that even if the animation is actually stopped in one point, because it plays in time, it will still play. And cycle is a very important part of motion layout, very, very powerful. So John is now going to cover that.
Okay. Yeah, so one of the parts that really I wanted to deep dive in this talk is on cycles. Since it's such a a little understood and a powerful feature that can lead to animations that sort of go beyond sort of ordinary animations, I thought I would talk a lot about it. So there are two kinds of key cycles, time cycles and key cycles. This particular effect you're seeing here is being done with about 4 or 5 different cycles, including affecting lighting and a whole bunch of other things. But you can see you can get very complicated with it. But let's just take a look at a simple cycle. This is a key time cycle. It's saying that this is going to happen at frame position 34. It's going to be about translating the X attribute so that any of the attributes that you can use in key attributes, you can use in key cycles, including custom attributes. It's going to specify the target. In this case, it's some particular button. The wave offset, which will allow you to shape the wave, and we'll talk more about that. The wave period. In time cycles, the period is frequency, so it's actually saying the hertz. And then the wave shape, in this case, a sine wave. Now, all of the properties that are being interpolated in the entire motion layout use monotonic splines, unless it's like a linear, unless you choose linear. And monotonic splines have a very particular attribute that they tend to not overshoot. So in this particular graph, the blue curve is what a traditional spline would give you. And if you mark those 4 points, you really would want it to sort of smoothly go to that area and then stop. The monotonic spline gives you that behavior, so you don't have these overshoots and then you'll have to add more keyframes, or you'd have to use B-splines to try and correct it. It just makes life a lot easier, and in all our systems we're using it. So in a key cycle, the 3 things that we're going to be interpolating typically is the period, the offset, and the attribute that you're manipulating. So let's sort of bring in a time cycle, a key cycle. And this key cycle is simply oscillating across translation X. And you can see it just basically shaking it and then collapsing back down. Now, let's manipulate some of the values. We can change the period. And there are 3 key cycles. And here I'm manipulating the middle one. I go to 3. A period of 3, a period of 4. The period value you can think of as how many waves the cycle is going to generate. And I took it up to period 9. The period is being interpolated to produce a smooth, continuous changes. I can also manipulate the values. And in this case here, I'm changing the shape of the waveform. So you can think of it as the envelope or the outer edge of the waveform. And you can even flip the waveform so it inverts, producing some interesting effects. Now, offsets can actually distort the overall shape of the curve. So you see there are lots of complex capabilities that you can make. And this is only doing with 3 key cycles. In this case, a sort of start, middle, and end. The other one you can do is wave shape. And in the first case is square wave, then we'll go into a triangle wave, and then a ramp. And ramp would move you from one and then jump back, ramp. And then if you need to go in the other direction, there's a reverse ramp, which would move you the other direction. Then there's a cosine wave, and you'll understand why we have a cosine wave later. And then the other one is a bounce. The bounce is unique in that it operates only on the top half, and it produces that bouncing motion that can be useful. So why we have sine and cosine? Now, we all kind of remember from our math that a circle is a sine and a cosine. A sine in X, a cosine in Y. Well, we can produce circles by taking 2 key cycles and having them apply one for translation X and one for translation Y, and one a cosine, one a sine. The nice thing about now that you do this is that when you manipulate things like the envelope of it, the outer edge, you can produce behaviors where it's a circle, but now it spirals out and spirals back in. You can also speed it up and slow it down because the cosine and the sine match each other and the waveforms are matching each other. So it's very powerful to combine multiple types of manipulations with key cycles. So here are just a couple of silly examples. The top one is sort of a button bouncing down stairs, in my opinion. And the other one is sort of a flight of fancy, if you can imagine a helicopter or something. Now, one of the tools that I worked on and we've put out today is the cycle editor. This is a tool that will allow you to manipulate multiple cycles together and actually interact with it. It's available on GitHub, and it's compatible with the key cycle XML, so that if you build a key cycle in it, the text in the bottom right-hand corner actually can be cut and pasted into a motion layout. Now, the other kind of cycle we should get into is key time cycles. Key time cycles take exactly the same attributes as key cycles. So everything I just talked about applies, except the period is in hertz. So it's literally frequency. And the interpolation of the period is now just simply adjusting the frequency of the oscillation in time. So in this case, you see the period is much higher and it'll just oscillate. And if you hold it still, as we saw in that demo, it will still oscillate at that period. And all the tricks, you can move it around, you can distort the waveforms anyhow you want, you can adjust the frequency at multiple steps and change it to produce any kind of effect you want. The ability to distort the offset is there as well, so the same principles apply, but in a very different pattern now. And you can see another example of it manipulating everything in real time. So you can do these effects and more with the system and build them in any rich combination. And remember, it's any attribute, so you can make things bigger or smaller, you can rotate them. All of these are done with key cycles. So now let's see how to put it all together into an applications.
Okay, so yeah, we really wanted to give you like a little more in-depth overview on the key time cycle, because that's the part that we haven't covered too much so far. Again, we just put out this tool that's on GitHub, on the ConstraintLayout Example GitHub, that allows you to play with the key cycles in a much more graphical, interactive way, and that's really nice. Please give it a try. Of course, you can use all the other stuff we talked about. Moving the position with the keyframe position, changing attributes with the key attributes, etc., etc. But at this point, I think hopefully you realize that yes, MotionLayout is cool. You can do a lot of stuff, but how do I use it? Does that mean that suddenly I have to throw away all my code and start from scratch? No, you can actually reuse a lot of your existing UI. In fact, that's actually something that I just want to point to you. With very little investment, you can take MotionLayout and integrate it into your current application without having to reinvent the world. So let's say that you have a coordinator layout and you may have a collapsible toolbar, but you want something a little more unique. So rather than doing it in code, you can simply replace the collapsible toolbar that you have with a MotionLayout view. And then you can, the sky is the limit in terms of what you want to do. Again, those examples are on GitHub. Check it out. This is pure XML, zero code. Well, actually, maybe just a little bit of code here to hook it up with the coordinator layout, but again, this is on the GitHub. It's really easy. So in the similar manner, if you have a drawer layout and you don't want to use the normal menu, why not go with something more fancy, right? Just go with MotionLayout enabled menu. That works perfectly fine. Same thing, if you have a view pager and you want a fancy header, you could build that with MotionLayout. And those are just image views, and we just build the parallax depending on the position of the view pager.
Okay, so now we talked a lot. You can create a variety of animations using motion layout, but in favor of MotionLayout Alpha 3, you can do even more. Let me explain some of the new features that were introduced in Alpha 3. So percent width and percent height. So let's take a look at the example first. This is an animation that tries to mimic the YouTube's app's thumbnail animation, where the top image is moving from the top to the bottom left. But as you can see, the animation doesn't look like exactly the real YouTube app. So with using percent width, the resulting animation looks like this. So the result is much more similar to the actual YouTube app. Let me explain behind the scenes. So if you take a look at only the cat image that is moving from the top to the bottom left, you notice the center of the image is transitioning along the X and Y axis, like this. Also, you notice that the size of the image is transitioning too from the top to the bottom left. And in the example, I put a key position that has a %x and the frame position equal 90. It means the delta x is kept 0 until the frame position 90. So it's not like the direct transition from the top to the left. Also, in terms of the size, I put percent width as 0 and the frame position as 90. That means the delta width is kept 0 until the frame position 90. So that will give you the much more better result in terms of YouTube's animation. The next one is multi-state. This illustrates a basic transition, and we have been talking about that's having 2 constraint sets and 1 transition. But from Alpha 3 and moving forward, it's now possible to define multiple, more than 2 constraint sets and multiple transitions. Let me show you the example. You can see like from at the bottom sheet, like a dial path is coming up from the bottom, and from the left side number drawer is appearing. So suppose these are the initial state, and the orange rectangle means the current state. By defining a transition 1, this will result in a state where the bottom dial path is showing. And using the same transition, it will go back to the initial state. And by defining another transition, it will brings the side navigation that will half visible. And by defining another transition, that side drawer is now fully visible. Yeah, that is how multi-state works. But please keep in mind that the state from the side nav bar is fully open, and the state where the bottom dial path is visible, you can't directly transition between them unless you define that transition. So in the example, I didn't put a transition between it, so now I can't transition between them. Key trigger. So let's take an example first too. So as you can see, the floating action button on the bottom right is hiding or showing based on the as the user is scrolling the content. So in this example, I put 2 key triggers. So let's take a closer look at the first key trigger. It has a frame position as 10 and on position cross as show. It means when the transition passes 10% and above, the show method of the floating action button is called. So similarly, if you look at the another key trigger, there is a frame position specified as 20 and on negative cross specified as hide. It means when the transition passes 20% or and below, then the hide method in the floating action button is called. So which is great because otherwise you will end up writing the custom code to toggle the visibility of the floating action button. But now you can define it in XML in a declarative way. Okay.
All right. So so that's Constraint Layout 2.2 and Motion Layout with currently Alpha 3. Of course, we're working on Alpha 4. So what are we working on? Specifically, we want to make sure that resize works really well. So what we mean by that, because you're like, well, isn't resize already working? Yes, but there are some situations where we could do a better job. And the specific situation we are thinking of is if you have, for example, a window that resize on the fly on a Chromebook running on your Android application, and we want to smoothly and completely transition everything on the fly. So that's going to come in Alpha 4. Also, visibility is a little strange. Like sometimes you want to change the visibility, but you don't really want, or you don't really think about it as impacting your state or your constraint set. But for us, at least until Alpha 3, the visibility is just part of the constraint set. So we capture the visibility, and you may have encountered that if you played with constraint layout, with motion layout, sorry, and you change the visibility, but then you play the transition, and whatever visibility was set in the transition override what you just did. One position would be to say, well, you just have to define your state correctly. You could also change the state on the fly, but it's a little heavy-handed. So one thing we will introduce in Alpha 4 is you can opt out of us dealing with visibility. So if you want to do simple manipulation of visibility, that's something you could do. Your next point is a little sadder, but we'll have to do a big attribute rename. So there's a bunch of attributes that we'll have to change. So Alpha 4 is going to be slightly painful if you already are playing with motion layout. We promise it's going to be the last time. That's why it's an Alpha 4 and not a Beta 1. Yeah, you will have to do some rename of some of the attributes. And the idea is that after Alpha 4, we'll do a Beta 1. And after that, we'll move toward the stable version. But yeah, there is some technical reason that we could not really avoid there. Sorry about that. And finally, a lot of people have been asking about RecyclerView and how do you integrate RecyclerView with motion layout? Because, okay, motion layout is great, but essentially you manipulate only the direct children. which is, as you saw in this talk, that can really take you very far. But RecyclerView is one of those examples where like, I really like to be able to do some motion layout stuff with my RecyclerView. Well, Keynote decided to crash. Okay, back. So in Alpha 4, we'll have some support for RecyclerView and MotionLayout. So what do I mean by that? What I'm talking about? Something. So imagine you have this screen and you have a RecyclerView at the bottom, and you may want some fancy animation when you trigger your element, right? How do you do that with MotionLayout? Well, one way that you can think about it is using MotionLayout not just to move your children as, or you are a component and you want to animate your content. You can think about MotionLayout as a scene choreographer, right? And here in that situation, what I really am interested in is fundamentally at a conceptual level, I've got those two views, like the green one that's representing my RecyclerView and the red one that represents an element in the RecyclerView. And I want to be able to specify the animation. And you can do that using the normal way that you manipulate anything in MotionLayout. The only thing you have to keep in mind is if it is to represent an item in RecyclerView, by definition, you don't know where that item is going to be on screen because you are going to move around in RecyclerView. So just keep that in mind when you build your animation, that the element is going to move on screen. But that's actually one of the real advantage of MotionLayout and how we specify motion. It's all reactive, right? It's all going to adapt to your screen size, to changing conditions, and etc. And that's one of the examples where even though that item is going to be moved, things are still going to animate correctly. In details, how does that work? Well, like anything in graphics, it's a magic trick. The general idea is we want to handle the gesture on your RecyclerView item. Specifically, in that example, I have an horizontal RecyclerView. If I'm swiping horizontal, I want the RecyclerView to handle it. But if I'm swiping vertical, I want to trigger something. So you need some kind of gesture handler there to distinguish between the two. Then we need to create a view that better look like the one you have in RecyclerView. So we are not going to manipulate directly the view in your RecyclerView. Main reason is if we were to do so, there would be a lot of issues with the life cycle, a lot of issues with bound, with clips and stuff like that. So what we are doing instead is give us a view, and we're going to take this view and map it where you define it in the animation. So we are going to rewrite on the fly the bounds of that view in the animation described in MotionLayout. And then we just run the transition, like any other transition in MotionLayout. So to make your life a little easier, we are going to provide some tools for that. So we are going to have like this class that will do the gesture handling for you. You only have to specify which motion layout you are targeting. The RecyclerView, because we'll use it, you'll see why. And the current view that you are intercepting the untouched event in. So typically here you'd pass this, for instance. And then in your view, in your item, you just use that instance and pass your touch event. So one trick here that we can do, and we're thinking about ways of making it more flexible, but one trick here is that view that we need to put into MotionLayout, well, RecyclerView already has a mechanism to generate those views. Right? That's what you use in RecyclerView to get the next view. So the idea here is that we'll use the adapter of your RecyclerView. And you have this view type parameter that you can pass, so that depending on the view type, your RecyclerView can give you a different view object. Well, you can specify the view type to pass to the adapter. So that way, if you do nothing, we'll simply use the exact same view you are using in your RecyclerView. But if you want to use a different type of view, For example, maybe like in your RecyclerView, you're using ConstraintLayout, but for the view you want to animate, maybe you want a motion layout because you want to go really fancy. While the view is animating, you want to move the content. That you can do by simply specifying a different view type. And then in your adapter, it's your job to create the right view. And here is a basic example again. So what's kind of nice, and that goes back to the whole stuff with MotionLayout, is that if I simply define the start and end, that's the type of motion you get. Cool, and it works on any type of view. I should have captured a video on that, but believe me, yeah, even if you move on the left, it will still work. But yeah, it's pretty stale. But because it's MotionLayout, it's trivial to spice it up, and then your imagination is the limit as well. So let's say that I want to delay a little bit the size change. Trivial. I just add a key position specifying that there is no going to be change until position 40. And that way, the element doesn't change, and it provides this little animation like that. But we could go a little further, of course. If I want to add this tilt that looks very fancy, I can just add a key attribute specifying the tilt. So that's kind of the big idea here, is that we'll basically offer you all the stuff that you have in MotionLayout to provide this kind of interaction. You'll notice here as well, it's a little subtle, but actually I'm going a little step further in that example. You'll see that the text, the description appears after a certain amount of time. It's because I'm doing another trick where I'm actually swapping another view while I'm past a certain step. So in a real application, you could imagine manipulating a fragment. Here I'm just using a view switcher, but you could use a fragment instead, and that way you would have life cycle for your components to only load the fragment when you are close to the full screen one. Okay, so sorry. Let's we're close to wrapping up this talk. So a couple of things. One, if you are asking yourself, okay, MotionLayout looks cool. When do I use MotionLayout? When do I use, I don't know, the Animator API? We actually gave a talk at the Android Developer Summit November last year. It's available online. It goes through all those details. So if you have those questions, check this talk. It's very informative, and you should have a better idea, a better handle of when to use which API. Roughly speaking, what we're trying to do with MotionLayout is to make things easier for you when you want to play with motion. And the way we think about it is we give you a lot of ways to declare stuff. So things are declared in this XML file, and we are trying to give you as much power as we can without having you to go back to code. Of course, there's some limitation in that approach. Sometimes you have to go back to code, and that means that sometimes you may have to, or you may want to directly access MotionLayout and do stuff in code. Or in some situation, it's just simpler to also use the existing Android animation API that are very powerful. One thing with being declarative is we can build a motion editor, and that's one of the things we're working on in the next few months. But that's kind of where we're standing. I'll remind you again, a lot of the documentation is available online. Goes into more details. We'll do more parts. For example, we haven't talked about key cycles yet, but that's the next part. The GitHub repository, very useful. You can see, grab the application, play it on your phone, play with the examples. Because one of the things that's very nice, I feel, with MotionLayout is when you try it on your phone, on your device, and you play with it, you see how it interacts. It's very difficult to translate that just looking at an animation on screen, how it feels in your hand. And finally, please give us feedback, right? We are building these things for you to make your life easier, and we really, really want to hear from you. The simplest or the best way for us is if you use the issue tracker. report bugs, obviously, but feature requests, don't hesitate. We also are, all three of us, pretty available on Twitter or Slack developer channels. So yeah, really don't hesitate. We want to hear from you. We want to make sure that we are capturing the full scope of what you want to do in animation with your application. And that's it for the talk. Thank you very much.